Welcome to my projectbazaar.com. Let us discuss about the outage property of energy harvesting relay-aided cooperative networks over relay fading channel. Let us discuss about the abstract of the product. So the energy harvesting technique is a potential way for relay node energy supply in cooperative networks with respect to deployment flexibility and maintenance charge reduction. However, unlike traditional power source, it is an institute that a fluctuation hours energy flow can degrade to the benefit resulted from relay-aided cooperative transmission. So to this end, this paper focused on the performance analysis of an energy harvesting. So the relay-aided cooperative network and a slow fading channel from a perspective of outage behavior and attempts deriving the closed form expression of outage probability of the proposed cooperative protocol. So compared with the simple direct transmission protocol, it is proof that a multi-cavity gain for improving the system performance in terms of minimizing the outage probability. So it can be obtained by energy harvesting relay-aided cooperative transmissions. So in particular, if there are multiple available relay nodes around the environment or the energy exhausted probability of relay node is small. So it is very profitable to employ the relay-aided cooperative transmission protocol. So in wireless low fading channel scenario, outage probability is one of the most important parameters of the system performance. Let us discuss about the flow diagram of the process. So these are the overall flow diagram. First of all, getting the system model, and the system model is going to the proposed protocol, and then the energy harvesting model. Finally, we're getting the performance analysis, and the performance analysis we're getting the particular outage probability. So these are the overall flow diagram. So first of all, the system model. In the system model, there are one source node and k number of relay nodes and one destination node. So for example, one source node is only one source node, and getting the k number of available nodes in the intermediate transmission, and only one destination node. In the k number of available nodes, it has an energy harvesting. So that is denoted by R, and one source node is denoted by S, and one destination node is denoted by the D. So the next of all, the proposed protocol. So in the proposed protocol, there are two protocols. One is a direct transmission protocol and another one is a relay-aided cooperative protocol. So in the direct transmission protocol, only one direct link between the source and destination is available. So thus all the time slots in a single block are used the direct link. So thus if the direct transmission protocol is employed, the overall data to the source and destination can be given by using the zero mean circularly symmetric complex Gaussian inputs. So next of all, the relay-aided cooperative protocol. So in the relay-aided cooperative protocol, both direct link and relay links are available from information transmission. So one relay-aided link then with enough available energy. So the case will the setup if the one only if the direct link to dictated leaded by the deep fading. So namely the cooperative protocol contains in the two steps. So one is the system aims to transmit information over the direct link, and one relative link, that is a case, so will be selected by activator to provide the alternative link instead of the direct link. So if it is also fails, an outage event will occur. So next of all, this is the energy harvesting model. So the energy harvesting model, it become a no energy and the energy exhausted. So in the no energy, at first consider the simple case there is a no energy storage device process RK, which means the RK can only utilize the energy harvester during the current block for current signal transmission. So if the harvester energy, that is EI, is less than PR, the relay will be the out of energy. So that means the energy exhausted. So the RK out of energy is called the energy exhausted probability. So finally we calculate the performance analysis in terms of outage probability, that is the SNR versus BER. So BER means the bit error rate. So calculating the outage probability, it should be minimum. Finally we calculate the performance analysis of the process. So overall flow diagram, this is the overall flow diagram of the process. Let us discuss about the running procedure for the product. So click the main file and then run. So the figures are related to our flow diagram. So there are I think there are 4 figures or 2 displayed. So let's take a time to run. First of all, this is the first figure. So the system model relay-aided cooperative network. So this is the system model relay-aided cooperative network. So there are one source node and there's a one destination, and there are k number of relay nodes. I will take that only 7 relay nodes in that. So the R1 is all the relay nodes are related to the harvester energy. So this is the x-axis and this is the y-axis. The source is in between the link. So the source to relay and relay to destination. For example, these are the relay-aided cooperative network. So the relay is in between the source and destination. So I will take the 7 nodes. The first node is R7 and destination, and R6 and R5 and an R4 and an R3 and an R2 and an R1. So this is the system model of the relay-aided cooperative network. Yeah, in this figure, the outage probability of cooperative networks as a function of SNR. So there is a signal to noise ratio. In the x-axis, we're getting the signal to noise ratio in dB, and in y-axis is the outage probability, that is in terms of probability function. So in this red is a P1 of EX. EX means the energy exaggerated is 0. So for example, if the energy is exaggerated between 0, so the red line like this, and the energy exaggerated with the 10 power minus 2, that is a blue line. So this is indicating the energy exaggerated with the 10 power minus 2, and the black is condition of 10 power minus 1, that is energy exaggerated from 10 power minus 1 to the black, and the green is energy exaggerated, that is equal to 1, so that is a green. So overall, the outage probability of cooperative networks and the function of SNR. So this is a description of this figure. Yeah, in this figure, the outage probability of cooperative networks, the number of available nodes. So the K is the number of available nodes. When K is equal to 0, the green is the K is equal to 0, and the black is indicated when K is equal to 1, and the blue is indicated when K is equal to 2, when red is indicated when K is equal to 3. So the y-axis is independent between the outage probability, and similarly the x-axis is the SNR of dB. So SNR is a signal to noise ratio. This is a calculation of the outage probability of cooperative networks, the number of available nodes, that is an K number of available nodes. So that is the figure of description of this figure. Yeah, this is the final graphs. The energy exaggerated probability at the relay node when the SNR is 20 dB and K is equal to 1. So like that, the direct transmission protocol, already I told there is a two type of protocol. One is a direct transmission protocol, and another one is an energy harvesting protocol. So the direct transmission protocol is like this, that is in ascending order is high to up, and the energy harvesting protocol is like indicating the black, and the stable power supply, so that is indicated the right. So the stable power supply is indicated by red, so that is a red color. So the energy exaggerated, always the energy will be exaggerated by the probability of the at relay node. So the SNR is 20 dB and the K is equal to 1. So the available number of nodes is K is equal to 1. So we will calculate the energy efficiency of the energy exaggerated versus the outage probability. So these are the overall running procedure for the product. Thank you for listening this video.